Hi everyone, we are group 5 from Physics 3 and today we'll be sharing about regenerative braking system. So, what is regenerative braking system? Regenerative braking is an energy recovery mechanism which slows down a vehicle or an object and converts its kinetic energy into a form which can either be used immediately or stored until needed. In simplified terms, the electric motor uses the vehicle's momentum to recover energy that will be lost to the brake disc as heat, and this energy will be converted into electricity. However, regenerative brakes can only be used on hybrid cars or electric cars. Some examples of cars using regenerative brakes are Toyota Prius, which is a hybrid car, and Tesla Roadster, which is a fully electric car. So firstly, I'm going to share a bit about how a conventional brake works. As you can see from the GIF, when conventional brakes are applied, the brake pads are pressed against the brake disc. This will produce a friction which slows down the wheels and stops the vehicle. Kinetic energy is then converted into heat as friction between the brake pads and the brake disc. This heat is lost to the surrounding and energy is actually wasted. However, on the other hand, instead of wasting energy, electric motors in regenerative braking systems can be used to recuperate at least a portion of kinetic energy for reuse. This system, which performs the function of braking, consists of a motor with dual function. So this will be the motor. And as you can see from the diagram, the electric motor works as a motor in one direction, which is shown by the green arrows here. And it also works as a generator in the opposite direction, which is shown by the red arrows. When it runs as a motor, battery supplies electricity. Electricity will then be flown towards the motor, and then electricity will be converted into mechanical energy to rotate the wheels and drive the vehicle forward. However, when driver steps on the brake pedal of an electric or hybrid vehicle, it runs in the opposite direction and becomes an electric generator, and this will slow down the vehicle. While running backwards, the motor, which is now an electric generator, converts the kinetic energy into electricity. The electricity will be then flown back to the battery and used to charge the batteries.
When the braking system is in driving mode, the battery supplies current to the motor's core. When this current-carrying conductor is placed in a magnetic field, it produces a catapult force which rotates the gear in the direction that makes the wheels move forward. This is proven by the Fleming's left-hand rule. The direction of the force is perpendicular to the direction of the current and the direction of magnetic field. When the regenerative braking system is in generator mode, it works in a different way which causes electromagnetic induction. Applying brakes to the system will cause a force to be exerted on the car's wheels and gears. Fleming's left-hand rule shows that an induced current is produced when a conductor cuts through a magnetic field. So, when the car's electric motors are changed into generators, the exiting rotation of the coils will cause a current to be induced, charging the battery in the car. Faraday's law and Lenz's law are applied in regenerative braking systems. Faraday's law states that the magnitude of an induced current is directly proportional to the rate of which the conductors cut through the magnetic flux. This means that when the car starts to brake from a higher speed, the coils cut through generators at a higher rate, which causes more current to be induced and stored into the rechargeable batteries. The Lenz law explains that a change in the induced current will cause the system to naturally oppose its change, trying to maintain its initial conditions. A change happens when a current is induced by the initially rotating coils in the generator. The systems then try to oppose the change by creating a current in the opposite direction. This causes the coils to slow down and ultimately stopping the vehicle. There are pros and cons when it comes to the implementation of regenerative braking systems. There are a few advantages when using regenerative braking systems. It improves the fuel economy of the vehicle as the consumption of the fuel is reduced. Regenerative braking system also prolongs the life of the car's batteries as it is recharged whenever braking. The conventional braking system will also face a lesser wear and tear as the regenerative brakes slow down the vehicle. The conventional braking system will also face a lesser wear and tear as the regenerative brakes slow down the vehicle. On the other hand, there are disadvantages when using regenerative braking systems as well. In general, the regenerative braking system does reduce the car's speed, but it doesn't really slow down the car entirely. Therefore, the conventional friction brakes still have to be used, meaning that the same energy is still being lost. The system also provides a different feel to the drivers when they press down on the brake pedals. It is described as mushy to some drivers. This may make some drivers lose confidence in driving with cars that use regenerative braking systems, and it is different from normal friction brakes.
So now, we are going to talk about the other applications of regenerative brakes other than in cars. Regenerative brake systems are also used in trains, making them more eco-friendly as they can reduce carbon emissions. These reductions are most effective for freight trains that travel very long distances. The regenerative brakes also extends the lifespan of the brake disc pads in the trains. However, it can be more costly to imply this technology into trains that are powered by DC currents, unlike those which are powered by the alternating currents, AC currents, as their power source. Another example where regenerative braking systems are used are in electronic bikes. Regenerative brakes can reduce the wearing of the brake disc of the bikes because it helps the bike's existing brakes to slow down and stop the bike. But there seems to be more downsides to this system being used in bikes. This is because when regenerative braking systems are implemented into electric bikes, the motor is engaged most of the time. This may cause the overall energy to increase, even more over the amount of energy which is generated by the braking systems. Furthermore, electronic bikes are not as bulky or heavy. This makes the benefits of regenerative brakes in electronic bikes minimal. Usually, the feature of regenerative brakes in electronic bikes are just used as marketing gimmicks. One other place which regenerative braking systems are used are in elevators. When elevators need to go upwards, a lifting torque is made by a supply of power to the elevator motors. This lifts the carriage upwards. And when the elevators need to go down, they require brakes to seize the kinetic energy and momentum which is created by their movement so that they can stop at the floors that they need to. And while this happens, the motor acts as a generator which converts the mechanical power into electrical power which is stored for future use. There are also foreseeable possibilities of the use of regenerative braking systems. There are many possibilities as, in theory, can be implied to anything that uses brakes. One of which could be aeroplanes. This could be effective as a lot of braking force is required when they land. The application of regenerative braking systems in planes could also extend the lifespan of their batteries, and the need for maintenance and charging could also be reduced if the regenerative brakes are implied.